I'd like to review those over the weekend action items problem. I left 3 problems for you to solve. Let's start from the very first one. The first one is about the Taguchi loss function, which is fairly straightforward. Taguchi loss function tells us the loss at dimension x when the cost constant k is k and the deviation from the target is this much, and you square it. Okay, so if you put down all the known parameters here, our t here is 5.9. And our penalty is 15. And I think our tolerance is 1.15. So based on these informations, we can easily obtain the value of k in here. Okay, value of k in here. So k is equal to, I think k is equal to the penalty at the spec limit. This is our k value. And then Taguchi loss function can sometimes also help us to calculate the loss for a certain process. So here this is going to be the variance of S plus the expected deviation, and this will give us the expected loss for the process, right? So expected loss is equal to, again, k multiply variance of the sample, all these guys, okay, and then this mean difference, average of your process minus the target, okay, and that gives us the mean difference where we square it, close parenthesis. I think it will give us the expected loss for this particular system. Okay, that concludes 17, which is pretty straightforward. And let's move on to number 20. Here, let's take down the known parameters first. This is actually a bad habit, that trying to solve a problem without knowing what the problem is talking about. But believe it or not, I'm actually repeating this video for, I think this is the 5th time, because of the microphone reliability issue with my computer. So what I'm trying to say is I've reviewed this question for multiple times, okay? You shouldn't do that. The question number 1. A is asking probability of tires surviving beyond 54,000. Okay, as you know, Excel will not give you this probability directly. Therefore, you need to do 1 minus P equal 54,000. Okay, so therefore the answer is 1 minus norm dist, what was it? 54,000, 50,000, 2,500, and true. So this is the probability. So if you're kind of confused about what this problem is talking about, I hope this is the last time ever I need to demonstrate normal curve. If you're familiar with this, you can just skip the video, okay? So here, center, 50,000, sigma is 2,500. Okay, so the first question is asking, survive beyond 54,000 miles. Okay, beyond 54,000 miles. So here we have a 54,000. Because 54 is larger than 50, therefore it is on the right-hand side of the curve. So what is this probability? Okay, so if you look at the next question, what it is asking is the fraction will survive fewer than 56,000 miles. 56,000? Fewer than that. Fewer than that. So as you can see, Excel can give the solution easily for this particular problem. So I'm gonna just do it in Excel immediately. Okay, B is P x less than or equal to 56,000. Okay, and this is norm dist 56,000 when average is 50,000, 2,500, and true. Okay, so yeah, this is a pretty plausible result. Nothing can last this long when the average is only like 50,000. Okay, and then draw a chart for the reliability. Draw a chart for reliability. Let's skip that for now. Let's take a look at number D. What length of warranty is needed so that no more than 2% of tire will be expected to fail during the warranty period? In other words, it is trying to say that what should be the so-called warranty limit. Okay, if you put 54,000 as a warranty limit or 56,000 as a warranty limit here, okay, you ended up having to service more than 99% of the tire you have released to the market. Okay, if this is your warranty limit, then you are busted because you have to service more than 99%. So what value of X you need to find out such that there are only 2% of total tire I can actually service. Okay, what should be this X that only have less than 2% before that point? Okay, so we are actually asking all the X's that is less than X is equal to 2%. What is such X? This problem can be easily solved by utilizing norm inverse formula, which I'm going to show you now. Okay, the larger X, the capital letter X, represents all the value of X's. Okay, is equal to 0.02, and then norm inverse 0.02. 0.02 mean is 50,000, 25,000, 2,500. So you only need three arguments here. That gives you the number. So if you set your warranty limit to 44,865.6, and that means you only need to service less than 2% of tires that you have released to the market. Okay, now let's move on to C, which is asking you to develop a reliability curve. I hope you still remember that reliability curve looks like what? Reliability curve in this particular problem's case, it will look like this, or it will look like this. If you're thinking of this as a reliability function, then you are wrong. And this is actually the reliability function. This is, if you must call it, this is the failure function, okay? The probability of failure. So let me take some steps to develop the function. So for the convenience, I'm just going to call it quality dimension X, okay? And then I'm going to do it in 2,500 increment. 2,500 increment all the way to, yeah, I think this will do. And then I can calculate probability of failing before X. Okay, then you can always have probability of surviving X. So this is norm dist here, and then absolute reference. Okay, standard deviation is this. Again, absolute reference, cumulative true. Okay, and double click. For this part, I'm going to do 1 minus this guy, and you double click. Okay, and then the reliability curve we'd like to draw, you need to select first column and the third column. Okay, you need to press Control key if you'd like to highlight two non-adjacent area, and insert recommended chart. So boom, this is the reliability function of X. Okay, yeah, these are what I have worked on earlier. You see how many curves I have today. I drawed 1, 2, 3, 3 the same thing. I'm repeating so many times for this particular module. Anyway, the last one is the last one. We have lambda known at 0.0000165. And mean time to fail, and it's going to be 1 over this. This is actually pretty reliable. It won't fail until more than 60,606 hours or so. And you'd like to know what is the probability of survive after, will not have survived after, will not have survived. I think it is less than, let me think about this, okay? Will not have survived. Will not have failed. Okay. Will not have failed, meaning that it all survived 20,000. Okay, so for this, you have two different ways of calculating it. The easiest way is to use the survival function, exponential negative lambda multiply with time, which is 20,000. Boom. Okay, and the other way of doing it is you utilize the expon dist function in Excel. 20,000. So expon dist actually gives you okay, 20,000 lambda is this guy. This is cumulative. Okay, and then of course the same probability what we're looking for is 1 minus this guy right here. Okay, not sure if yeah, if you have time. So I'm not sure your version. My textbook tells me to draw reliability function to verify your answer visually, so I can just go ahead and draw reliability function. Okay, so again, I'm going to be using the quality dimension as a word. Please start from 0 when you develop a exponential or survival curve. So I'm gonna do 5,000 increment on here. Okay, and then I'm gonna do 100,000 increment after that point, because Excel can help us smooth the curve, so it shouldn't be too big of a problem. Okay, and then this is a probability of surviving x. Exponential and negative lambda multiply with quality dimension x. But what I like to do is I'm going to do F4, the absolute reference, to fix that. So double click. We got pretty plausible result, and we need to visually confirm it by drawing the reliability curve. Voila, we have a reliability curve. So it is letting us to visually verify whatever we have. So 20,000 hours is somewhere here, right? It's not visible, but I'm pretty sure. Okay, I'm pretty sure that 20,000 is here. So anything before this point, the size of probability. This proportion. Okay, I'm lucky. I'm glad that I pointed this out. This portion is telling you the probability of failing before this point. Okay, but what we are really interested in this case is the probability after that point of 2000. Means the probability of out surviving at that 2000. Here, is it 20? I'm sorry, it's 20,000 instead of 2000. Okay, this concludes the question set. I'll see you next video. Thank you. Ooh.